1.7 applications using linear equations. Again, it's just word problems, you guys. Well, I say just word problems. Let's look at how this goes. So this is not a surefire way to solve word type problems, okay? But it is a good way. If you can get into a rhythm with these 5 steps, and you're in good shape. But sometimes writing the equation, depending on what type of thinker you are, you may do better just not even writing the equation at all and just solving it like a regular problem. And in some cases, even drawing a picture may be helpful. But one thing I would like you guys to always do on this list, well, really 2 things, is the first and fifth steps. Okay, and I'm guilty of it. You guys are gonna throughout this semester, you guys are gonna see that I'm gonna skip reading the entire problem, and when I do, I make mistakes. Now, for some of the, like if you guys really struggle with these word type problems, you may have to reread it several times. Just expect it, okay? If you're good, maybe you have to read it twice. If you're really good, maybe once, okay? But always read the problem, at least read it once. And then the fifth step is just to check your answer. We've been doing that mostly with the calculator, but if you guys can get used to doing that, again, it's you'll have a pretty powerful tool in your pocket, not only for math, but I guess generally speaking. So this table just kind of gives some basic wording or phrasing that you may be or may not be familiar with. I guess it doesn't matter. But like that, when you see the word is, that's a pretty direct translation into the equal sign, okay? Or the same as, it's not as common, but the word is. Sum is addition. It's the answer to an addition problem. Specifically, more than generally indicates that we're adding value to something. Difference, that one is not as well known, but difference is subtraction, you guys. Now this one right here is one we got to be careful with, less than. All right? Now let's talk about that after we go over the rest of these. Product is a multiplication problem. And when you see the word of, it can be, it depends on the context it's used, but they say it's multiplication. And they used x's for multiplication. We really shouldn't be doing that. We should have dots for that. But to say that of is always multiplication, it just depends on the context, if you ask me. But let's address this less than business. So let me put something on here, and then we need to be able to interpret this stuff, right? Less than, well, let me compare with difference, actually, okay? Difference is very direct, but less than is very indirect. So if I said 30, I'll make it a little bit easier, okay? 30, we'll make it 30 less than, 50. Now, if we even tacked on some labels on this, you'd be like, oh, that makes perfect sense. But if I said $30 less than $50, then the question would be, well, how many dollars do you have? And once we talk about money, it's like, dude, I already know it's 20 bucks. And I like 20 bucks. And I hope you like 20 bucks as well. I would like lots of 20 bucks. But that's 20 bucks right there. And so it's 30 less than 50. But does it come out as 30 minus 50? And the answer to that is no. We don't. It's not 30 minus 50. When it's something less than the other, generally the first number actually kind of comes second in that problem. So it ends up being 50 minus 30, which is why we get 20 out of that, okay? So when you see less than, if you see less than, just be careful with it because it reverses the order of the numbers. Whereas if I said the difference between 30 and 50, yes, that is directly 30 minus 50. So again, that one depends on, the order is dependent upon the wording. With addition and multiplication, it doesn't matter because they're commutative. If you use the commutative property, order doesn't make a difference with those 2 specific operations. All right, translate the following verbal statement into an algebraic equation and then solve. We'll use x. That's good. I like x. 3 times some number plus 1 is 7. What is the number? So it did say to translate this, and I believe you got to do that on the homework where you got to actually write the equation into a box. Now let's go ahead and do this, though. It says, let's start with 3 times some number. Well, what does that mean? It means we're going to take 3 and multiply it by a number we don't know. So I've got to use the unknown in this case, which is x. plus, hopefully that's pretty direct for us. And I did read it, by the way, but I also am reading it again so we can go through it, right? Again, that's part of reading it multiple times. So plus is this, well, plus sign, addition. What are we plussing? We're adding 1. So right now I got 3x plus 1. This is a good interpretation. Is, we should know that is the equal sign, and what it is 7. It is 7, okay? So I've directly translated this wording into an equation, a two-step equation. That's not too bad. I like these two-steppers, and it's, yeah, let's go ahead and solve this thing. So we'll subtract 1 from both sides. That's going to zero out the 1, which is going to make this 3x now equals 6. Some of you guys know the answer, but I'm still going to show the work, okay? Divide both sides by 3, and we get x equals 2. So the number, what is the number? It is 2. Bam. And we can check. 3 times 2 is 6, plus 1, it is 7. That's correct. So it gives us a true statement. Now here's another one. Yeah. The wording on this one is a little bit different, but it also is going to produce a very similar type of an equation. In any case, on this one, the difference of 5 times a number and 9. Well, difference we need to know is subtraction. So I'm just going to put the subtraction sign, but what is the difference between? And it didn't use the word between, or what is the difference of? Well, it's the difference of 5 times a number. So we got to show that as 5x, and using x as the variable, and 9. So and 9, there we go. There's a difference between 5 times the number and 9, 5x minus 9, which is, so there's our equal sign, 8. Oh, sorry, there's more to it. 8, see, that's, I almost didn't read the whole thing. Is 8 less than the number? There's the less than thing, you guys. Be very careful with that. So it's not 8 minus x. It's not, where was I there? 8 minus x. It's not this, okay? Don't write that because it's 8 less than whatever the number is, so you got to actually take the number first and then do 8 less than it. Okay, just like we talked about before. Well, this is set up now very well for us, and it's not a two-stepper, but it's, 3 steps, I would say. And, we could do it in 1 step if we wanted to, but we're going to do it in 3, I guess. So I'm going to say that I'm going to keep the x's on the left, just because it's the most common place to put the x's, not that you have to. So I'm going to get rid of that minus 9 right there and zero it out. I'm going to add 9 to both sides of the equal sign. There it goes, zeroed. Which now is 5x equals x plus 1. And then I've got this 1x right here, which I need to get rid of because it's on the wrong side. So just subtract 1x from both sides, making that 4x equals this 1 right here. And then finally, to solve, I want 1x, not 4x. So 4 divided by 4 is 1. Just got to divide on both sides. So now x equals, I'm going to keep that as a fraction. I like fractions. Well, I like fractions more than decimals. They seem to be easier to write. But this one I am going to check just because it is a fraction and I wasn't really expecting it. I'm not saying it's wrong. I just wasn't really expecting it. So let's check. Did it correct? I was just a little unsure if I had done that right in my head. It just seemed weird. So I checked in the calculator. There we go. It shows that as long as I've written the equation correctly in the beginning, that this would be the solution. It would make this original equation true. Now let's read through this one. I'll try not to make the same mistake again. Consecutive numbers are 1 unit away from another. Consecutive odd and even numbers are 2 units away from each other, which is, it's really only important if you're going to use an equation. And I'm going to use an equation on this one. It's just not required that you do. I'm going to use the equation method on this one, and I don't really need that stuff up there because right now they're just consecutive integers. It didn't say that we had to use x, but I am going to use x. Actually, I'm going to define x very specifically on this one, okay? So I'm going to define x. I'm going to say x, I'm going to let it be the smallest number. X is the smallest of 3 numbers, right? Smallest number. There we go. All right, so that means that it's the sum of 3 consecutive numbers. So I'd have my small number plus the next biggest number plus the biggest of the three, and the sum is 66. So I'm setting up my equation on this, starting with my smallest number here. Now, if x is the smallest number and the next one is consecutive, because it's an integer, then it would be the smallest number but one more than it. And I want to keep these all in terms of the smallest number so that I only have one variable on this, which means that the next biggest number, the biggest of the three, is 2 more than the smallest number. Now some of you guys may be like, well, I want it to be the biggest number. That's fine. It's just that then you'd have to make this x plus 1, it'd be 1 less than it, right? Like your biggest number would be here, this would be 1 less than, and then this would be 2 less than. So it's going to give you the same answer either way, it's just going to give you it in a different order. So this is set up, and yeah, like some people are like, dude, I'd like to see parentheses around those. Okay, feel free to do it, man. Because the parentheses can help us, our brains, to kind of see the difference, right? Like x is the smallest. So, well, I actually don't like to see the parentheses there. So I'm going to take them out, you guys. I know it makes it look a little bit sloppy, but I can still read that pretty good. Now, I took the parentheses away because we wouldn't even need to distribute anything. But again, if you like to see them there so that it kind of helps you to separate where the numbers are, I think maybe the color coding does that as well, okay? So right now, I'm in an equation. I can combine my like terms because there is no distribution. I didn't want that marker. There you go. Now that's 1x, 2x, 3x's right there. And then I've got my constants, 1, 2, 3, bam, plus 3 is going to equal 66. So, I mean, there was no distribution. If you had parentheses, you may have chosen to distribute a phantom 1, but it's not necessary. Now we're at a two-step equation. I want those 3x's isolated, so I'm going to get rid of that plus 3 by subtracting 3 from both sides of this equation, which gives me now this 3x equals 63. Finally, we'll make that a 1x by dividing both sides by 3. 1x now equals 21, dang it. There we go. 21. Now, by the way, when it asked for the answer, it didn't ask for one answer, right? It said list the numbers from smallest to largest. Well, I know, just because I wrote it out, and I remembered, by the way, that x is the smallest number. Now, since they're consecutive integers, the next number would have to be 22. And then the next number, the third number in this sequence, would have to be 23. It's just one more than the previous one. Well, that's pretty good, right? Like, wow, dude, that was a lot of work, a lot of interpretation, a lot of analysis, and we feel good inside. Our hearts are warm. However, you should check this, okay? You should check it. I'm going to go to the calculator for it. Not that everyone has to. But I'm just going to type into my calculator. What the heck? 21 plus 22 plus 23. And what should it equal? It needs to equal that 66 because it said that the sum was 66. And this is how it's going to check off. Bam, 66. So those three numbers from least to greatest, or smallest to largest, are the three consecutive integers. All right. So translate the following verbal statement into an algebraic expression and then solve. I'm going to translate this into an equation. I said expression, I meant equation. I'm going to translate it into an equation just because it says to, which means I think on the homework it's probably going to force you guys to as well. But you don't have to solve it using the equation because sometimes you don't want to, okay? So this one says the sum of three consecutive even integers is 174. List the numbers from smallest to largest. So this is my second method, which is related to the one we did on that last problem. But like I did on that last problem, I'm going to define my x on this. Okay, I'm going to say x is I'm going to keep it the smallest because then it's going to allow me to incorporate addition into this problem. So x is the smallest number here. So I've defined my x. I know what it is, what it represents. And now it's time for the equation, right? And it did say it's the sum again. So no difference on this one, which would be subtraction, but it's the sum. I got a number here, here, and here, and it's going to equal whatever the sum is, which it said is 174. Now, we don't know what the three numbers are right now. Some of you guys do, because you can do math in your head, and that's awesome, but I'm going to show it anyways. X is the smallest, and I always just put X as my smallest number on the far left. And these are even integers, though, okay? So my next number is not only bigger than our smallest, but it's 2 bigger than the smallest number, because 2 more than the previous, in this case even, would get you to the next even number. So the next even number would be 2 more than that, which compared with the smallest number is 4 more. Okay, so like, you know, what, 2, 4, 6, these would be consecutive even integers, where 4 here is 2 more than 2, but 6, the third one, is 4 more than 2, okay, and that's why we got plus 4 right there. Now, I'm not saying the answer is 2, 4, and 6. I'm just giving you guys an example of that stuff, okay? So I'll get rid of that garbage. All right, now, you could solve this exactly the same way that we did that last problem. It's just solving a regular equation, a multi-step equation. Combine your x's, combine your 2 and 4, subtract the 6, divide by 3, okay? But I'm going to do this a different way, and I like this way, actually. Whether you like it or not is really up to you, okay? But 174, I know it's the sum, and there's other math that we can relate to sums of many values. And what I'm talking about specifically is what math nerds call the mean. You guys would probably call it an average, unless you're nerdy like me, then you'd call it a mean. Well, a mean is where you take lots of numbers and then you add them together and divide it by however many numbers there are, right? Well, 174 is that sum, and we're going to divide it by however many numbers there are, in this case 3. And this is going to tell me the average. Well, what does an average tell us? Sorry, let me do this actually. It should be 58 right there. So 58 is the average of the 3 numbers. Well, what is an average? It tells you, an average is going to tell you the middle. So right now, the middle number is 58, which means that the next lowest even integer would be 56, and the next highest one would be 60. Now, if I've done that right, that should be the answer right there, 56, 58, and 60. It was pretty quick. Again, you may not like it. I loved it, though. It was great. I feel good about myself, you know what I'm saying? But let's just check to make sure I did it right. Okay, I'm going to take 56 plus 58 plus 60, 174, bam. So, again, it's about manipulating these values and taking control of them and then forcing them to be what you want them to be, because using the equation, it's going to give you the 56, but if you want to use an average, you could. In fact, I could do that on that last problem. All right, as promised, let's do this one with the second method, okay? So again, we know that the sum is 66. All right, now these ones are consecutive integers, so it's not like they're 2 away from each other. But again, I'm just going to use the average on this one. So the average would means I'm going to take all the sum and then divide it by 3, which is, well, 22. See how that's that middle number right there? So 1 less than it is 21, and then 1 more than it is 23. Bam, 3 consecutive integers that add up to 66. Or if we have time, but for now, I don't know why it's number 6, but whatever. The rectangular room is 11 meters longer than it is wide, and its perimeter is 134 meters. Find the dimensions of the room. And yeah, we'll use x. Well, maybe we'll use more than x. Now, I don't know about you guys, but I like to draw pictures of this stuff. Not because I'm good at it, or that I should like it, but I do. I just like it, okay? And right here it says that it's 11 meters longer than it is wide. So if this is my width right here, which I'm going to represent with W, not X, then the length here is going to be 11 meters longer than that width. Now if I wanted perimeter, I like to see all 4 sides. So this side would be W plus 11, and then that short side is another width, W. And to find the perimeter, what you're going to have to do, perimeter, it's going to take all 4 sides added together. So W plus 11 plus W plus 11. I can separate the different sides with a different color for that so we can see the different side lengths there. And in addition to that, it even told us the perimeter. So I'm not even going to use P as a variable right here. I know it's 134 meters. So 134 right there. And then I've produced an equation that can be solved, which will give us the width, but it wants all the dimensions. So not only do we want the width, but we're going to have to figure out the length as well. So, well, yeah, a little bit more space on this would be good. So let's combine some W's here. 1, 2, 3, 4 W's. And again, if you like to see those phantom 1 coefficients, that's good as well. But I also have some 11s that I can combine to make that plus 22. So as of right now, I've got 134 plus 4W. Again, we're just solving this with regular principles of equality and equation solution processes, whatever. I want to get rid of that plus 22, subtract 22 from both sides, so that's going to be 112. Yeah, that's good. And this equals 4W. We'll divide both sides by 4 now to get just the width, which is going to be 28 meters specifically. Yeah, don't forget to label your word problems, you guys. Now that felt pretty good. We did a lot of work there. However, we need all the dimensions, so we're going to figure out the length as well, which is the width, but 11 more. And as of right now, we know that the width is 28, so I'm going to replace it with 28. And that's going to tell me what the length is, 39 meters. Now, I could stop there, and it'd be like, dude, that was a lot of work, and I feel really good about it. But I'm going to check on the calculator by adding all 4 sides, as far as I know, right? The width is 28. The length is 34, and then plus another 28 plus another 34 equals 1. Oh, I said 34. I meant 39. Dang it. 28 plus 39 plus 28 plus 39 equals 134. Ah, that works. That works. So even though I typed it in incorrect, now I see that we have it correct. There we go. Perimeter, distance around an object. I like the picture that I drew, even though you may not like, but rectangles is usually pretty good to help us with that stuff. But just so you guys know, just this last part here, this is really math nerd stuff. Like if you were like, dude, I don't care which is longer, length or width. In terms of math, people, not that I care, but some people do, length is usually the longer of the 2 sides. So on this one, a rectangular room is 7 times as long as it is wide, and it has a perimeter of 64 meters. Find the dimensions of the room. Well, what did I tell you? I was going to draw a picture, right? Full of art. I feel like it's like cross-curricular, you know what I'm saying? And not that it matters which side is which, but I know that the length of this room is 7 times as long as the width. So again, if I say the short side is the width, not that I have to, but the long side is 7 of those widths. And I know it's not proportional right now, but maybe someday it will be. And this one is dealing with perimeter, so I'm going to show all 4 sides. At least the values that I have right now, even though all 4 are related just to the width. And yes, perimeter is the same as all 4 sides added together. So width, 7 widths, another width, and then another 7 widths. If you guys are using a different formula for perimeter, that's fine, like 2 parentheses width plus length. I like to see all 4 sides just so that I can account for them in my mind. Otherwise, I kind of feel a little uncomfortable about it. I think this one's easier than the last one because I got 1 there, 7 there, another 1, and then another 7, which totals 16 of these widths. And yes, we do know the perimeter. We know the perimeter because it told us it was 64 meters. So 16 widths would give us 64 meters, but I want 1 width. So we'll divide both sides by 16, and that tells us that the width is 4 meters. Well, if the width is 4 meters, then the length is just 7 of those, so multiplied by 7 is the length, 28 meters. I'll put equals L, not that you have to, but again, before I box these in, I just want to check my work, right? Because width plus length plus width plus length should give us, in this case, 64 meters. So I'm going to go to my calculator. Hopefully I type it in right this time. 4 plus 28 plus 4 plus, whoop, let's see, I did it again. 4 plus 28 plus 4 plus 28. There we go, I did it. 64, bam. So I see my width is 4 meters and my length is 28 meters. I'm going to use an equation on this one. Well, I think it keeps it more organized, okay? But a bag is filled with red and black marbles. Usually it's green and blue, but whatever. There are 57 marbles in the bag. If there are 19 more red marbles than black marbles, find the number of red marbles and the number of black marbles in the bag. So red and black marbles, okay. Now this brings up a couple equations for us, by the way. And we'll say red, here I got red marbles, so R is the number of red marbles. And then, well, B is for the number of black marbles. When I add those together, it should be all the marbles in the bag, you guys. That's 57 marbles right there. That one's pretty good. The other thing I know, though, is there are 19 more reds than blacks. Okay, so if you took all the black marbles and then you added 19 marbles, you'd get the red marbles. So the red is equal to this black marbles plus 19 more marbles. Okay. And yes, there's different ways to solve this one, but it's a little bit more confusing than that average stuff. So what I know right here is that red equals black marbles plus 19. So if I go back to this equation, right, the red plus the black marbles, red plus the black marbles equals 57. Well, I know what red equals now, and this is leading into something a little bit more different, which is going to come in later. I can replace all my red marbles with what we have up there as black marbles plus 19 marbles. Okay, now this creates the reason why this is nice is because it creates an equation with only one unknown, which is what we've been solving. That's what we've been doing this whole unit so far. And that's what I'm going to do. I got one B and then two B's right there combined. Two sets of black marbles, what that would be. Plus 19 marbles is going to be 57 marbles right there. And then we'll subtract 19 marbles from both sides. That would tell us how many marbles would be in two sets of black marbles. And, well, what the heck is that? 8 and 4, 38 right there. So if we had two sets of black marbles, we'd have 38 marbles, but we don't want two sets. We just want to know how many is in one set of black marbles. So to solve this one, we'll divide both of these by 2. And the number of black marbles then is 19. Black marbles. Black marbles. Here we go. That's not bad handwriting for me. Well, if there's 19 black marbles, and we know that there's 19 more red marbles, then this red number of marbles just becomes 19 plus 19, which is, well, 38. 38 red marbles. Now, before I box this in, I'm going to check. And you can do that on your calculator if you'd like, but 38 plus 19, that'd be 40, 57. Bam, that's how many marbles we know are in the bag. So I know now that these are the two answers we need. Read it. A board that is 36 feet long is cut into two pieces. One piece is 12 feet longer than the other. How long are the pieces? Well, again, a picture may be helpful in this case. So if I said, that's the board when it was before it was cut, right? And then this is 36 feet long. And yes, I know that when you cut this thing up with the saw specifically, it's going to take out, like a 1/8 of an inch or something like that. Don't get that specific, you guys, because I'm not going to write tests like that. Neither will the department, for that matter. But we're going to cut this into two pieces. So, bam, I cut a piece. I just know that both of them together need to be 36 feet total, right? What I see on this one is that one piece is 12 feet longer than the other one. So if my short piece, which is this one, if I said that the short piece is X, then the long piece is the short piece, but with 12 more feet. All right, and I can make an equation pretty directly out of this. I got my my long piece, X plus 12. And then I got my short piece, which is just X. When I add these together, I should get 36 feet, which creates an equation for us. So there's one X and another X. That's two X's. Then we got this plus 12 business. equals 36. Subtract the 12 from both sides. And then 2x equals 24. Yeah, just divide both sides by 2 now to get the x. X equals 12. Now that's the short piece. It wants to know how long the pieces are. And yes, we should label this. Don't forget to label your word problems, please. Now what the heck? The long piece is 12 feet longer than that, so if I add 12 to it, then I get 24 feet as the long piece. Now we should check. I really don't need to, but let's check anyways. 24 plus 12, how long is it? Bam. 36 feet, which is how long the board was in the beginning. So that checks off. So a board is 75 inches long, is cut into 2 pieces, same as the last one. So before I draw, I almost got ahead of myself. Let's not draw yet. Let's read the rest of this. The longer piece is 9 times as long, or longer, than the other piece. How long are the pieces? All right, so again, I like to draw this out. And again, this full piece would have been 75, I guess, inches. But again, we're going to cut this thing into 2. One's short, one's longer. And again, it doesn't matter if they're proportional or not. If it bugs you, then, get a scale out and then good luck with that. But for me, it says that the longer piece is 9 times as long as longer than the other one. So again, I'm just going to say that x is the short piece, and that the long piece we know is 9 times as long as it. So that's 9 times x, you guys. Which does set up the equation for us once again. We got the long piece, 9 times the short piece, and then the short piece, when I add those together, I should get 75 inches. Well, this isn't too bad. Just combine your like terms. We only got this set of like terms. 9x's plus 1x's, 10x's. Seems like I missed something on that, but the longer piece is 9 times as longer than the other piece. Well, I think we're doing that right. It's going to give us a decimal. That's going to be okay. This is 75 inches. So the short piece, if I had 10 of the short pieces, it would be the full length of that original board at 75 inches. But I just want to know how long one of them is. So I'm going to divide that by 10. And x, the short piece, is now showing at 7.5 inches. Now that's not an exponent, you guys. That's an inch mark if you're not familiar with it, okay? So that's 75 inches without actually having to write inches or in. Well, if the short piece is 7.5 inches, then how long is the long piece? Well, it's 9 of those, right? So I've got to take 9 of those short pieces, 9 times 7.5, and that's going to tell me how long the long piece is. But I'm going to need a calculator for me. I don't know about you guys, but for me, I need it. 9 times 7.5 is 67.5. Again, that's in inches. That's the long piece. But just to check on this, it's the same idea. 67.5 plus the short piece, 7.5 inches, bang. It shows it's 75 inches. So I know that's my long piece there, and that's my short piece. That's how long the pieces are.